Okay, I forgot my JavaScript. The bug was here. Set interval of 0 is not a good idea. Not a good idea at all. We want to do timeouts. Interval means you do this every 0 milliseconds. So just it just keeps doing it. And every time it does it, it would do it more. It would like more than exponential. Wait, is that exponential growth? Probably. Yeah, it's well, 0 to be mathematically correct. That's like undefined amount of increase. So yeah, we want to use timeout. If we use timeouts, we get working. Yay! Yeah, so these circles could stand to be a bit bigger. Would I do that? 4 plus that, so at least 8, and at most 16. See how that looks. Yeah, let's have it back down there. Yeah, I like this sort of spread of magnitudinal difference between them. Anyway, yeah, that looks kind of cool. That's nice. It's like floating in liquid. These are bubbles or something, debris. You're like getting a bath. Anyway, anyway, back to the topic at hand. So in our circle, when it processes all the circles, you know what? We can't have them going off screen. We need to have them stay in the screen, which involves have them bounce back in. So we'll do that. That's the in-circle process. So after it gets its new position, it checks if that's an acceptable position. Okay, so if this dot x is this dot x minus this dot radius. So when its edge is less than or equal to 0, that means it's hit the thing. Actually, just less than 0. Yeah, that means it's hit the thing. So we want to oh, let me think about that. Alright, so there's the edge, circle is here. So what we want to do is this distance, add that to the x, I think. Yeah, when I add this distance to the x, so it's, back into the world. Or even, this is how much it was able to go in. So really, that's like the bounce should have happened a bit before, a bit backwards in time. And if the bounce happened a bit before it got to this stage, it would have moved this distance. So really we want to move it from being here, this point from being here to being over here. So this distance, if this is x, this is radius. X minus radius is that. So this distance will be x minus radius. Yeah, gives us that as a negative. So then we want to do negate that to get this place, and then just add the radius to get x. Yeah. So this dot x equals negative of that. So it's this dot radius minus this dot x plus the radius. So that's times 2. I'm just trying to see if I can. So you go there, and then you go there, and then you subtract x. Really? That works? Really? Wait. What? You know what? I'm gonna do this pen and paper, see, just in case, because that was just in my head. So I'm gonna make sure I get this right. Alright, it's correct. It's just like when I tried to visualize it, I visualized it wrong. I did like plus r from there, but really it's plus r from here, and then plus r minus x, and that looks more correct. Yeah, so this is okay, and I'll put this 2 at the front here. So x goes there, and then we reverse dx. Okay, and now what about the other side? Well, I just recalculated that on that piece of pen and paper, which you can't see because it's not on the computer. But anyway, so if this dot x plus the radius is greater than or equal to the width, then x equals, this is a bit bigger, 2 times the width minus 2 times the radius minus x, which isn't so much different. Anyway, yeah, that's what I expected to come out as. I calculated that by hand. So y will be pretty much just the same. So let's see if we've got some bouncing circles. They bounce, they bounce, they bounce as I want them to. Awesome. So next step is have them bounce off each other. Yeah. Okay, so this is where the real collision detection comes into play. This is cool. Yeah, it's cool. Yeah. So in process circles, first I'll do the really inefficient way, which is just have everything compare with everything else. So yeah, every possible pairing of circles will be made. All of them. All possible. So that ends up being quite a lot. Already made that one. Yeah, so lots and lots of lines everywhere. So as the number of circles goes up, it gets quadratically bigger. It's like n squared on 2-ish, something around there, or n minus 1 squared on 2, whatever. Just quadratic. And what I aim to do for the optimization isn't not quadratic, but basically just split this space up into grids. Each circle puts itself in one of those grid places, so all it does is check within that little box. So it's still quadratic, but you're reducing that number by like to a 50th, no, that's a bit much, to like a 20th. So there's only about 10 circles in one place. Yeah. So first things first is the inefficient way, and the efficient way will come later once we make sure everything is working as we want. Okay, so circle 1 equals this. You gotta be careful. You can't do this and do, like, what I want to do now is do have a j for j equals I plus 1. J is less than circle list dot length j plus plus. You can't do this because JavaScript sucks. This I is actually a string. It is not a number. Even though it's going over an array, it treats these as strings. So if you do I plus 1, like if I is 0, j will become 0, 1. And like if you try to do circle 2 equals circle list j, you'll get an indexing error because circle list does not have 0, 1 as a key. So I can't do this anymore. I have to do it like this, which sucks. Anyway, JavaScript has many advantages and stuff, I'm sure. Okay, so we have pairs of circles, and it doesn't do any pair twice because